Hi, you guys. I wanted to give you just a quick little cheat sheet, and I wanted to do this video to walk you through the cheat sheet. So you had this for your quiz today. So here's the this little one-pager is a good summary of what we've done so far in the quadratics unit. So we started out by looking at these quadratics, which we know are a little bit different than linear equations because they have this x squared term. So y equals ax squared plus bx plus c. That's the standard form of a parabola, and we know that that's going to make something like this. It's going to make this curved function, okay? A curved function. So there's the y and there's the x, and we'd have this curved function. Now, what we do is, you know, the a, b are coefficients. They go with either the x squared term or the x. And then the c is a constant value, so it doesn't have an x term. And so here's a good example of one. You can see the coefficients are 2 and 3, and the constant is 4. Okay, so I've just mentioned that here. So it says the one factor that identifies these expressions as a quadratic is the exponent 2 on the x. So the first term must always be ax squared, so a cannot be 0. If a was 0, then it would be a linear function. Okay, so a couple other things. Here we go. You know, we covered the two main forms that we've covered so far are the standard form of a parabola and then the factored form of a parabola. In the standard form, I don't think I actually mentioned this, but the if you have a parabola in standard form, you technically know the y-intercept. So you know the point at which that parabola crosses the y-axis. You know that point right there, and it's 0, c. Well, I'm not sure why it did that. Oops, let's try to stop this. Okay, a couple more things. If you look at the a term, here's the a term. Remember, it goes with the x squared. If it's positive, you know that the parabola opens up. So it'll be like this. And you know that if it's negative, it'll open down. So it goes like this. Okay. When looking at the factored form of the parabola, the factored form is probably a little bit more useful. That we can get the zeros, or where it crosses the x-intercepts, we can get those because we can look at r and s. So look at this, we'll look at the r and the s. And I put a little note in here, remember to change the signs. So if, for example, it was y is equal to x minus 2 and x plus 1, that we know that the zeros are technically x equal to 2 and x equal to negative 1. Just remember that those are the x-intercepts. You got to change the sign. We also know that the axis of symmetry is just r plus s divided by 2. So in the case that I just gave you there, the axis of symmetry would be 2 plus negative 1 divided by 2, and so that would be equal to 1/2. So that's the axis of symmetry. And for the vertex, all you'd have to do is sub in the x value, basically sub in this value from your axis of symmetry back into your original equation, and that would give you your y value of your vertex. So that's a neat way of getting the vertex. Okay, a couple other quick things. Here's a graph. So there they are. That's where there are the two x-intercepts. There's the y-intercept and there's the vertex. Those are some of the things that you should be able to identify. So in this particular case, I'll just tell you that the equation of this parabola look at this. It's got an x-intercept at looks like it's at about -1/2, and at 1, 2, 3, 4, maybe 4.5. So this one would have an a value, and then it would be x. Oops, it would have an a, and then it would be x plus 1/2, and then x minus 1, 2, 3, 4.5. Okay, so I wanted to remind you that you just got to change the signs when you're getting the x-intercepts. Now, I don't know what the a is. I do know that the a must be negative on this one. The a must be negative because the parabola is facing down, but I'd have to substitute a point in to get that, and that's what I mentioned down here. I said to get the equation, use the x-intercepts to fill in the r and the s, so that's kind of what I did there. And then substitute a point in. So I would substitute, like I can see that this vertex is at 2, and then 1, 2, 3, 4, 2, 4, 6. I'd substitute 2, 6 in. Everywhere I see an x, I'd substitute 2, and everywhere where I see a y, I would substitute 6, and that would give me the a. And I know it's negative. I'm not going to do it here because I just wanted this to be a quick review, but you can see that you could plug it in and solve for your a. One other thing that we did definitely do was we spent a lesson using FOIL, which is a short form for first, outer, inner, and last. And so you use that to go from factored form to standard form. So look at this. I did an example here. So if I wanted this parabola right here, I know there's no a value for this. So technically that just means the a value is 1. I want to remind you of that. But here, if I wanted to go from factored form to standard form, I go first. So x times x is x squared. And then I go outer. I go x times -3, that's -3x. And then I go inner, 2 times x is 2x. And then I go last, plus 2 times -3 is -6. And then I just combine my two like terms, which are those two, -3x and plus 2x, and I get -x. So look at that. In standard form, it's y is equal to x squared minus x minus 6. And so these two right here are the same parabola. One's in factored form, one's in standard form. Okay, so that's a nice review, a nice little cheat sheet there. Hopefully you guys could use that in your quiz today. Take care.